Alright, let's put that nightmare away, and welcome to day 25 of Advent of Code, everybody. I've been traveling again, so obviously starting a little bit late, 9:23 instead of 9 p.m., but let's go ahead and get started. Day 25, full of hot air. As the expedition finally reaches the extraction point, several large hot air balloons drift down to meet you. Crews quickly start unloading the equipment the balloons brought, many hot air balloon kits, some fuel tanks, and a fuel heating machine. The fuel heating machine is a new addition to the process. When this mountain was a volcano, the ambient temperature was more reasonable. Now it's so cold that the fuel won't work at all without being warmed up first. Oh. The elves seemed to attempt to make the new machine feel welcome, had already attached a pair of googly eyes and started calling it Bob. To heat the fuel, Bob needs to know the total amount of fuel that will be processed ahead of time so that it can correctly calibrate the heat output and flow rate. This amount is simply the sum of the fuel requirements of all the hot air balloons, and those fuel requirements are even listed clearly on the side of each hot air balloon's burner. You assume the elves will have no trouble adding up some numbers and are about to go back to figuring out which balloon is yours. You get a tap on the shoulder. Apparently, the fuel requirements use numbers written in a format the elves don't recognize. Predictably, they'd like your help deciphering them. You make a list of all the fuel requirements, your puzzle input, but you don't recognize the number format either. For example, 1 equals -0 -2, 1 2 1 1 1, 2 equals 0 equals, etc. Fortunately, Bob is labeled with a support phone number. Not to be deterred, you call and ask for help. That's right, just apply the fuel amount to the... Oh, for more than one burner? No problem, you just need to add together our special numeral analog fuel units. Patent pending. They're way better than normal numbers for... You mentioned that it's quite cold up here and ask if they can skip ahead. Okay, for special numeral analog fuel units, SNAFU for short, are sort of like normal numbers. You know how you start on the right, normal numbers have a ones place, a tens place, a hundreds place, and so on, where the digit in each place tells you how many of that value you have? SNAFU works the same way, except it uses powers of 5 instead of 10. Starting from the right, you have a ones place, a fives place, a 25s place, a 125s place, and so on. That's easy. You asked why some of the digits look like a dash or an equals instead of digits. You know, I never did ask the engineers how I did that. Instead of using digits 4 through 0, the digits are 2, 1, minus, and double minus. Minus is worth -1, and double minus is worth -2. So because 10 in normal numbers is 2 5s and no 1s, in SNAFU is written 20. Since 8 in normal numbers is written 2 5s minus 2 1s, it's written 2 minus minus. You could do it the other direction too. Say you have the SNAFU number, 2 double minus minus 0 1. That's 2 in the 625's place, double minus in the 125's place, 25 minus in the 25's place, 0 in the 5's place, and 1 in the 1's place. 2 times 625 plus -2 times 125 plus -1 times 25 plus 0 times 5 plus 1 times 1. That's 1250 plus -250 plus -25 plus 0 plus 1, 976. I see here that you're connected via our premium uplink service, so I'll transmit our handy SNAFU brochure now. Do you need anything else? You ask if the fuel even work in these temperatures. Wait, how cold? There's no way the fuel, or any fuel, would work in those conditions. There are only a few paces in the... Where did you say you are again? Just then you notice one of the elves pour a few drops from a snowflake-shaped container onto one of the fuel tanks. Thank the support representative for their time and disconnect the call. The SNAFU brochure contains a few examples of decimal normal numbers and their SNAFU counterparts. 1, 2, 1 double minus, 1 minus. Cool, alright, so it's just everything's offset by a little bit, that's fine. Based on the conversion, the SNAFU numbers in the example above can be written as follows. In decimal, the sum of these numbers is 4890. As you go to the input this number on Bob's console, you discover that some of the buttons you expect are missing. Instead, you are met with buttons labeled minus, double minus, minus 0, 1, 2, and Bob needs to input the value expressed as a SNAFU number, not in decimal. Reversing the process, you can determine that for the decimal number 4890, the SNAFU number you need to supply to Bob's console is 2 double minus minus 1 double minus 0. The elves are starting to get cold. What SNAFU number do you need to supply to Bob's console? Get your puzzle input. Okay, so let's start with the simpler stuff. So level 25, first we have to replace L15 with L25, replace all. Fantastic, let's go to main.java. 25.part1, and that should be imported now. And so we basically want how many numbers are there? A lot. Okay. Long sum equals 0L string SNAFU number equals scanner.nextLine. For int I equals SNAFU number dot length minus 1 I is greater than or equal to 0 plus plus I or minus minus I. Let's actually go I is 0. I is less than snafu number dot length and plus plus I, and we'll see why we're doing this in a second. So now I want long place value equals math.pow, and I want it's 5 to the it's snafu number dot length minus 1 minus I. Is that right? Yeah, so the last one will be to the 0 because it'll be snafu number length minus 1 minus snafu number length minus 1. Same as plus 1, so that should work out. Let's get the music going again. That should be fine. What are we upset with here? Long dot value of. Okay, Java. Long power. Java number of power. Well, that's not helpful. Oh, perhaps I can just cast it. Cool. Long place digit equals long place digit switch snafu number dot char at I case double minus case minus case. I guess everything else is just default. Case double minus place digit equals minus 2 L. Then we want to break here. Place digit equals minus 1 L. Break. Otherwise, place digit equals long dot parse long snafu number dot char at I. Does that play nice? It does not. Okay. Rather than trying to figure out the right default case, we're just going to case 0, case 1, case 2. And let's just copy this stuff. We can put it in there, there, there. 0L, 1L, 2L. Great, cool. So, let's see. And then I want a long this. Snafu decimal representation equals 0L. Yeah, now I could. Yeah, I'm trying to think if I could just like add the number and then move it over, and then add the number and then move it over. Does that work? Normally that would work for 10, but for this, not really? Okay. Although I just in my head figured out the algorithm that we're gonna have to use to solve this problem, which is fine. Let's check Twitch chat real quick. Okay, nobody's saying anything in Twitch chat, but is anybody here? A couple of people are here. That's cool. Interesting. Well, Merry Christmas to you guys. If it is Christmas. So place digit. We already have place digit. We have FU decimal notation plus equals place value times place digit. What are we upset about? It definitely was initialized. There we go. And when we get done with this, then we have sum plus equals. What am I looking at this? Snafu decimal representation. Great. So we're putting this just because this gives us a breakpoint, and let's put in our test input and see whether or not it reads stuff correctly. Heck, let's do this. And let's debug real quick. Let's make sure we're doing all right. What are we upset about? Oh, why are we not building now? Build project. Maybe I can get it to rebuild the project. Rebuild project. Like I can see that it's not here in the out, but it's getting mad that these things aren't here, and I could just delete them, but I'm curious why it's not there. File not found. Okay, that's better. There we go. Alright, cool. And that's because in util, we need to change our file helper to instead use the laptop version. Fantastic. Okay, so now it runs, and now if we debug, let's see, did we get it right? 1747, 906, 98. So if we just go here and we say play, 4890, fantastic. Okay, cancel. So now we want private static long or string long to snafu number long value. So now what I want to do is I'm going to build it like normal, and then I'm going to edit it. So first, private static string long to base 5 long value, return long dot to string value 5. Is that right? To string, what is the radix? And then the first end character used the radix end digit, substitutors, radix 16. Fantastic. Also cool. So yeah, this should go. What is min radix? 2, max radix 36. That is fine by me. Seems good. Okay, string base 5 representation equals, we can actually just put this here, long.toString value 5, while base 5 representation dot contains 3. Or nope, come on. Base size representation that contains 4. I want like the last instance of 3 or 4. Actually, it doesn't matter. Int 3 index equals base 5 representation dot index of 3 4 index equals base 5 representation dot index of 4 if 3 index equals -1 index plus equals it's -1, then I actually just want to make it equals base size representation dot length, and same with 4 index, and I'll use that in a second. So if actually we can just split it this way: if 3 index is less than 4 index and 3 index not equal -1, then we're just going to use 3 index, else use the 4 index. So let's grab the first one. That's fine. So the 3 index is coming first. If 3 index is 0, and then else we want to do something else. So if it's, and let's do not equal 0. No, let's do 0 first. So if 3 inches equals 0, base size representation dot caret 0 dot set. See, Java string set car string set caret index. Let's make this a string builder. New string builder. Nope. String builder. Fantastic. Doesn't have contains. And code point index insert. Okay, never mind. So undo that. Cool. So base 5 representation equals new string builder. Base 5 representation. Why is this a dot? Set care at 3 index. And if it's 3, then it becomes this. Let's move this down there. Actually, move this here. Don't care. Come back to this. Move everything to the left. Move this here. Builder equals new string builder dot set caret whatever blah blah blah. and then it needs to be 1 plus, right? That should be fine. Cool. And otherwise, this is probably not the cleanest way to be doing this, but that's fine. Okay, string builder. So equals dot get. Oh, that's not what I want. Switch base size representation dot char at 3 index minus 1 case double minus case minus. Let's just copy these cases real quick. Here we go. Case double minus, then we want builder dot char at 3 index minus 1. What? Char at exists? So can I do builder dot char at whatever? Yeah, I can. Case equals, and so I want sat char at index minus 1. And if it's minus minus, I want it to be minus and break. Now we can copy this. And we can just do this. Index minus 1. This is now going to be 0. This is now going to be 1. It's now going to be 2. This is now going to be 3. Which is fine. It'll go forward. That's okay. And so now we basically want to do the same set of things. Else we know it's 4 index. We want 4 index equals 0. 4 index. And 4 index should just be minus. We move 1 to the thing above. Is that right? So say we have 4. Instead we want 5 minus 1. So we're going to add 1 to the one above. I want to subtract 1. Otherwise we want 5 minus 2. So we add 1 to the one above and we'll put it into minus 2. And that was for a 3. Yes, this works. And it'll just keep percolating up, which is fine. If we went right to left, it'd probably go faster. That's better. What are we upset about? Else, we're at x minus. Or next minus 1. And we still want to, the same set of things applies, right? Because it doesn't, we're always still just adding 1 to the one base up. So that should be fine. And after all of this stuff, this one, return, base 5 representation. So for this, we want to print out foo rep of sum plus equals plus, and I want long to snafu number sum. And we can get rid of this. It straight up doesn't get called. Cool. So what happens if we stop and rerun this? stop and debug. Cool. Space size representation is 1, 2, 4, or 3. Cool. 4 index is 2. There's a 0. Minus. This is a 3 now. Oh, what happened? Ah, we didn't. Oh, gosh. Base size representation equals builder.toString. We need to do the same thing up there. Sample termination condition. Alright, rerun for me, baby. Fun to see you working in part, but okay, string next bound, next minus 1, length 6. Okay, no, that's okay. Here, let's debug. Let's see what's going on. Cool. 124030. 2 minus 330. We got some stuff wrong here. Okay, let's stop again. So 124030, that seems right. 4 is less. It should be a minus. Char at 4nx minus 1, which is 1. Should be 3. Oh, these all need to be 4 index. Okay, now stop and rerun. Okay, we're still off by something. There's a conditional wrong. So far, so good. That looks better. Let's go and see. Oh, crap. Well, that's, yeah. If 4 index equals minus 1, then we can do the 3. Otherwise, we know we're dealing with 4 index. Okay, that should be much cleaner. Two equals minus 1 equals 0. Okay, cool. Let's run it on our real input now. And hope it's not too big. Oh, not the right answer. Turn to day 25. Let's start with a minus or a double minus or anything, right? Yeah, that should be good. Okay. Let's let's just run that and see what comes out. Oh, still nothing. This is what we put in last time. 1 second, go back. 2 minus 20 equals minus 0. 1 equals minus 0 equals 0 equals 0 equals 2 minus 1, 2, 0. And let's make sure, did we get the right answer when we did this? 2 equals minus 1 equals 0. Cool. So we run this again. Do we get the same thing that we got wrong last time? Just making sure that I got all the input. Cool. So what is this number? Java long max value. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 digits, and this is only this snafu implementation minus long dot max value. In fact, let's do it this way. Cool. Seems like we're fine. Yeah, this should be okay. Where's the bug on what we're doing? So let's take this input again and find the issue. Stop and rerun. If, what do I want? Belong to snafu number, snafu depot representation dot equals non-reflexive translation. That breakpoint here. Let's do this. Snafu number. Cool. And so what's long to snafu number? Snafu number decimal representation. 1 0 0 0 0 0. Okay, let's set a breakpoint here. String incorrect translation equals long to snafu number, snafu decimal representation. Let's attach that there, and then let's debug. Stop and rerun. Let's see what's going on. So let's step in. Let's copy this into. Nope, not what I was looking for. Here. So that's the string we're trying to get. Come back to here. This base 5 representation. Whoa. Why is that? Not toString value 5. What, are there non-unique representations here? Okay, let's see. So let's take value. Let's copy that. Put it here. Nope, I'm looking for Wolfram Alpha. Thank you very much. Base 5. What? How does that work? Plus minus 10 plus, or I guess let's put it as minus 2 times 5 plus 1 times 5 to the 0, 5 to the 1, 5 to 2, 5 to the 3, 5 to the 4, 5 to the 5 plus minus 1 times 5 to the 6 plus minus 2 times 5 to the 7 plus 2 times 5 to the 8 plus minus 2 times 5 to the 9 plus minus 1 times 5 to the 10 plus minus 2 times 5 to the 11 plus 1 times 5 to the 12. Okay, so the number that we got is wrong. Okay. Does this seem right? How does it compare? Similarly. Okay. Where is that? 1 equals minus equals 1 equals minus equals. Oh, it's like the very first number. Okay, well, great. Cancel. Stop and rerun. Oh, well that's, I just put the debugs here in the wrong spot. Cool, let's put debugs here and here. Let's see what's going on, stop and rerun. Yeah, that's fine. So all there's mad at is this, which we could straight up do by hand, but... Oh, no, this is not the number that we care about. Keep running, please. I also don't care about that, just... Okay, there we go. Alright, now we should be on the right track. Yeah, and this seems to be going fine. Log to snafu number. Snafu decimal representation. 202 equals 0 equals minus 2. Okay. Let's see what's going on. if we look at this, it's 4045359. Okay, so let's take where we are. Let's dive in. This, what is our base 5 representation? So 2, 0, 1, 3, 4. Probably do need to proceed right to left. Oh yeah, because it assumes that the digits are correct over here. Yeah, cool. Alright, cool. Let's rewrite our little iterator here. It's actually just 4 into I equals base 5's representation dot length minus 1. I is greater than or equal to 0. 0. Minus I. If base 5's representation dot caret I is 3, else if base 5's representation dot caret I is 4. Cool, so it is 3. So for 3 we can use this. Instead of 3 on x, if I equals 0. I. Actually, we can just control R. 3 index. I. Place all. Thank you very much. Else, and this should be this. Yeah, that looks better. We do actually do the same with 4 index. Replace all. Cool. So now we can just get rid of this part. Going from right to left should be good. And so now, if we run this, are we going to get an error? Or are we just going to get a number out? Okay, cool. Debug. Show me the non-reflexive translation. So, along the snafu number, snafu decimal representation. 1 equals, 2 equals, minus, 1, minus, equals 0. Crap, okay, cool. Step in. Is that the first one? It is the first one. Okay, so something about what we did is subtly wrong. False, false, cool, we're good. Yeah, it's probably getting weird because we make a 5 go somewhere. Step over. There's a 3. Or if we look at long dot toString value 5 44430. Now it's 444 equals 0, so it's getting that wrong. Cool. So let's figure out what happens. Yeah, don't save this. Alright, so I want to write a little helper function actually. Private static int char to int car c. If c is return -2 if C is return -1, return integer dot parseInt C new string C. Plus C. That should work. Okay, cool. So now I just want so let me write some better logic here. So instead of all this nonsense, I want I need to deal with 0 kind of separately, with the 0th index separately. If base 5 representation dot char at I char to int C is greater than 2. Static char int2 char int I. If I is -2, return this. If I is -1, return this. Otherwise, return character dot. Alright, why don't we just integer dot toString I dot char at 0. That's gross, but it'll work. I want int to char, yeah, cool. So int place value equals this. If place value is greater than 2, our new place value equals int to char I minus 5. So then I want string builder equals new string builder base 5 representation builder dot set char at. So it should be I minus 5. It should be place value minus 5. Alright, I new place value builder dot set char at I minus 1. And then I want char to int base 5 representation dot char at I minus 1 plus 1. And then I want Instacar. Yeah, should be fine. Char to int should just, yeah, it'll give me the right thing, otherwise it'll be fine. And then I need to check. Yeah, this seems much better than all this switch casing. Much better. And now I just if char to int base size representation dot char at 0 greater than 2. And then I just want to do this same thing, but slightly differently. So why don't I just do the same thing, but for 0. So instead of this card int stuff, we're just going to do place value 5. So it's set at 0 as place value. And then I want base 5 representation equals builder.toString. I keep forgetting to do that. And then for this one, instead I want base 5 representation equals card int should just be 1. And we're always going to be adding a couple. Like, it shouldn't ripple up that much, so it should be fine. So it was 0, so it should just be 1. So it should just be 1 plus builder.toString. Fantastic. Now run. Stop and rerun. Or the console. Okay, I got a slightly different answer. 2 minus 2, 0 equals 0, 1 minus 0 equals 0, blah, blah, blah. That looks better. Let's try putting that in and see if we got it. Subtle bug there. Right answer, part 2. Part 2, the hot air balloons quickly carry you to the North Pole. As you land, while the expedition escorted directly to a small building. It'll take 50 stars, only 49 stars to go. Did I not log in? I'm logged in. I have all these things. Has finished warming the... Okay, here, let me read it all. Part 2. The hot air balloons quickly carry you to the North Pole. As soon as you land, most of the expedition is escorted directly to a small building attached to the reindeer stables. The head smoothie chef has just finished warming the industrial-grade smoother blender as you arrive. It will take 50 stars to fill up the blender. The expedition elves turn their attention to you and begin emptying the fruit from your pack onto the table. As you do, a very young elf, one you recognize from the expedition team, approaches the table and holds up a single star fruit he found. The head smoothie chef places it into the blender, only 49 stars to go. You have enough stars to start the blender. You make a smoothie with all 50 stars and deliver it to the reindeer. The sleigh is already warmed up by the time they finish eating. Congratulations, you finished every puzzle in Advent of Code 2022. I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via contact info on my website or through Twitter. If you'd like to see more things like this in the future, please consider supporting Advent of Code and sharing it with others. To hear about future projects, you can follow me on Twitter. I've highlighted the Easter eggs in each puzzle just in case you missed any. Hover your mouse over them and the Easter egg will appear. Yep, just like that. There's at least one in the description for each day. Oh cool, so there's little Easter eggs. And I'm rendering colorblind, so what is... I can't tell what this is. Look at these little guys up here though, that's cool. Oh, is it a mountain and another... Yeah, I can't see what this is at all. I hate being rendering colorblind. Okay, let's go through and see if we can find some of these. Where's the Easter egg? Etc. By etc, you're pretty sure they just mean more snacks. Your reason? Why do you keep guessing? Jungle journey. Where there's jungle, there's hijinks. This is kind of fun. I'm not sure that I really... If you like this, you'll love axis-aligned bounding box intersection testing. Okay, well, I'm gonna quit reading these and maybe I'll come back to them later. But let's go ahead and finish off as we do, and then I'll explain what's going on here. So let's take this. Let's scroll up. Let's zoom in just a little bit. Okay, I can't. Fine. Now let's go to the top and see what we need to bold. Fuel heating machine. Nothing, nothing, nothing. Amount is simply the sum. Cool. This. telephone number. Okay, we're looking for Here we go. So we're looking for 2, 1, 0, minus, written this, and double minus, written this. Snafu, it's written 20 cents. 8 in normal numbers written this is written 2 minus. You can go in the other direction. So you have this. Oh gosh, it's gonna make me do all this. Gross. Double minus in this place. Minus in this place. 0 in this place. Gotta click to get that music going. Oh, thanks to the zombie killer whale. I just saw your message. Hope you're still around. So let's find out if you're still around. You are still around. Thank you. Merry Christmas. And I just lost my place in what I was doing, but it was worth it because I got to say thank you. Okay. 0 and a 1 in the ones place. Here, blah, 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 blah. So now we can just skip to the end of this line. That's 976. It's how cold? There's no way the fuel or any fuel would work in those conditions. And the guy hangs up on him. Yeah, screw that guy for being curious about what's going on in our life. We're out here trying to, keep secrets from people. Cool, so we gotta put the stuff into Bob, I love that he's slamming proprietary languages while he does this. Okay. Run the decimal number, share this. So put it in Bob's console is this. So getting cold. What snafu number do you supply? Bob's console. Puzzle answer was this. Oh, and part 2 is just a story. Letter balloons. Notice that engraving on the equipment. Balanced quinary industries. Okay. Head smoothie chef. I'll take 50 stars. Yep. Excellent, excellent, excellent. Okay, not a lot to comment in the code here. But let's do it anyways. Oh, and we actually wrote a little thing that can make this go away. So place digit equals char to int snafu number dot char at I. Yeah, and then the int should come along. That should be good. There we go. Which apparently is unnecessary. Fantastic. So that should be better. We can get rid of these because now we don't have any issues. Yeah, excellent. The base 5 representation. Proceed right to left. Fix each character along the way. That's pretty much it. So basically what we do is we take in the numbers and we, read in the weird base 5 that we get, which is fine. And then once we do that, we add all the numbers, and then once we do that, once we have the sum, then we just need to turn this into a snafu number, which is a base 5 representation, except it's a base 5 representation without 3 and 4. So what we need to do is we need to replace all the 3 and 4s, so if anything is greater than 2, because sometimes you'll have a 4 and you'll add it to it, so then it's a 5, then what you need to do is you need to move the move the digit. And so what you do is you say, okay, make this value 5 less and make the next value 1 up because it's base 5. No problem there. So then you just go through, you do that, and then you fix the 0th character where you have to add 1 to the front, and then you're done. You just return that representation where you use a little bit of, char to int into char magic, or you deal with your 2 special cases, and otherwise you just return the nice little conjunction of these things. Runs plenty fast. Let's see what our stats were for the day. Actually, I never saw personal stats. Yeah, 2892, 2312. That's unsurprising. We started 20-30 minutes late, and we didn't go very fast. So that's not a great thing for us, but if we check out our private leaderboards, I'm the only person to have done today, so unsurprisingly, I'm on the West Coast. Not many people are, and not many people are spending their Christmas Eve. And we're 1 shy of having completely dominated this. What a shame. Oh well. Anyways, that's going to be all for Advent of Code this year, folks. So I hope you enjoyed it. I hope you had a good time. As always, you can find VODs of this content on YouTube. I'll go ahead and get to editing this last one so it can be done for the year. And yeah, I hope to see you all around sometime soon. Most of the time on Twitch I stream chess, so if that interests you, feel free to drop on by. And if it doesn't, no big deal. Not a huge deal there. Alright, I think I'm going to call it a night. Bye, everybody.